This video is for Chapter 11, Section 2, and it's all about the surface area of prisms and cylinders. We've just started looking at three-dimensional figures, and this is the first time we're going to work with certain three-dimensional figures, prisms and cylinders, because they are related to each other. So first we're going to take a look at prisms. A prism is defined as a polyhedron, so many surfaces, that's what polyhedron means, with two congruent parallel bases. This is the really important part about prisms. You must have two congruent and parallel bases. Now when we look at this shape here, a box, it might be the front and the back that you call the bases. It might be the two sides or the top and the bottom. But when you look at this shape here, this is a triangular prism. The only two congruent parallel parts is the triangle on the bottom and the triangle on the top. Those become the bases. Here's a trapezoidal prism. Well, it has a trapezoid that is on the bottom and on the top. They are congruent and parallel to each other. It is very important to identify the base before you start working with a prism. Now, the other faces or surfaces are the lateral faces. So that, if we consider the front and back to be the bases, then everything around would be the lateral faces. Here are the triangle prisms. Well, everything going around would be the lateral faces. Now, the height of a prism is defined as the perpendicular distance between those two bases. That's another critical aspect to prisms. You must be able to identify the height. That is the distance between the bases. Now what I've done here is I've unfolded these prisms and created nets. We just studied nets previous to this. So here is the net of the cube, where the front and the back I'm using as the base, and the other four surfaces are the lateral faces. Here's the triangle, and here are the three surfaces. Now notice each of the three surfaces match one side of the triangle. This matches this side. The longer side matches the hypotenuse, and then the third side, which is the shortest, is over here. These are the sides that wrap around the prism, and they are always rectangles. This is very important to us because we're going to use rectangles to find the surface area. Those rectangles all have the exact same height. That is the height of the prism. The distance between the bases, the distance between the bases, the distance between the bases. Again, here is the trapezoidal prism's net. It has one side matching. These sides here match the legs. And then this final side here matches the top of the prism. It's really important that we look at the nets of prisms because they are going to help us understand that to find the area, the surface area of this shape, we have two parts. The lateral faces, which seem to always make a rectangle, and the two bases. So let's take a look at how we find the surface area. But before we do that, we are going to take a look at one just technical term. If the prisms are perpendicular between the bases, we call it a right prism. So here, the pentagon prism going straight up, trapezoid prism perpendicular between the bases. But here, this is an oblique prism. It's like taking a stack of paper or a stack of CDs and sliding them to the side, and it makes the Leaning Tower of Pisa. We will not work with oblique prisms with surface area, rather only volume. So now, let's take a look at the lateral area of this box. Now I'm talking about A, B, C, D being the base, and these rectangles all going around all have the exact same height, which is right here, H. Now, to find the lateral area, we take this rectangle right here. And a rectangle's area is base times height. The base of this rectangle is A plus B plus C plus D. A, B, C, D. That is the perimeter of the base of the prism. we're going to abbreviate perimeter of base with capital P, lowercase b. Perimeter of base times height. That will always find the lateral area or the lateral surfaces of the prism. So this is the first of the major formulas we're going to study this unit. Lateral area equals perimeter of base times height. Now, at that point, the only thing we're missing are the two bases. So the surface area is the sum of the lateral faces plus the two bases. So I have the lateral area, which we already found, perimeter of base times height, plus 2 capital B. We're going to use capital B to signify area of the base. In this particular case, the area of the base is a rectangle, so we would just find the area of the rectangle and multiply it by 2. If the base was a trapezoid, we would find the area of the trapezoid and multiply by 2. Same for triangle or a pentagon or even a hexagon. So that's how we find the surface area of a prism. We find the lateral area, perimeter of base times height, and the surface area, we add two bases. Let's take a look how this is related to cylinders. Now, cylinders are exactly the same as a prism, except for their base is a circle. Since a circle is not a polygon, we don't call cylinders prisms. But the circles must be parallel and congruent. It can be the Leaning Tower of Pisa, or it can be a right cylinder. From here, let's take a look at, check out what happens if you unfold, and you can do this with a bottle of water at home or anything that has a wrapper around a cylinder. If you take the wrapper off, you'll find that the wrapper creates a rectangle. The height of the rectangle is the height of, say, the can. But the length of the rectangle is one length around the circle, and we call that circumference. So the length of this rectangle is circumference, 2 pi r. Circumference is another word for perimeter of a circle. So we have perimeter of base times height. Just specifically for circles, 2 pi r. That's perimeter of base. So the equation is virtually the same, except for we have a very specific perimeter of base formula called circumference. After that, we just have the two bases that we have to add, and those two bases are circles. We already know the area of a circle formula. That's pi r squared. So we can still say the surface area is LA plus 2 bases, or surface area equals LA plus 2 pi r squareds. If we want to, we can go ahead and put that because we are acknowledging that we already know the base is a circle. Okay, so let's take a look at an example of how to use this work. We'll only get 2 examples really quickly. Here is a triangular prism. Most importantly, identify the base. The triangles are the base. Okay, so now the formula for the lateral area is perimeter of base times height. Well, what's the perimeter of the base? One side is 3, plus the other side 4, plus, question mark. Well, good thing this is a right triangle, and we can use the Pythagorean theorem. We'll make a little note of that. And so, using the Pythagorean theorem, we will find that the third side is 5. This is a 3, 4, 5 right triangle. So, my perimeter of the base is 12. My height is my distance between the bases. There is my height, 6. So my lateral area will be perimeter of the base, 12, times height of 6, and 12 times 6 is 72. And that would be meters squared. Now, to do surface area, I just need the lateral area plus 2 bases. Well, I already have my lateral area. It's 72 meters squared. I need my capital B. So, it's a triangle. Let's use the formula 1/2 base times height The base of this triangle is 4, the height is 3, so 1/2 of 12 is 6. But remember, that is only one base. I need two bases. So my surface area is equal to my lateral area, which is 72, plus 2 bases. 72 plus 12 is equal to 84 meters squared. So that's one example. I'm going to erase that example real fast and show you a cylinder, but there's your basic example of how to work with the surface area of a prism. Now, let's draw a cylinder. We've got our little circular top, circular bottom, and we'll give it a diameter of 10 inches and a height of 12 inches. And we need to find the surface area of this cylinder. Plug in the formulas. Lateral area equals 2 pi r times height. Well, my radius is equal to 5 inches, not 10, that's the diameter. And my height is equal to 12. So we have 2 times pi times 5 times 12. 5 times 12 is 60, times 2, 120 pi. This is my LA. That is the area of the wrapper around the can. My surface area is LA plus 2 pi r squareds, or bases. So let's figure out that capital B, which is pi times 5 squared, which is 25 pi. And now we can say that our surface area represents 120 pi, lateral area, plus 2, 25 pi. That would be 50 pi. 120 pi plus 50 pi is 170 pi. And then we have inches squared. And there is our surface area. This answer is left in terms of pi, so this would be the exact answer. At this point, you would go to your calculator and you could plug in 170 times pi to find your rounded approximate area. We will do more examples of these in class, including hexagons, pentagons, and some of the tougher shapes. But for now, that's it for surface area of prisms and cylinders.